All right, this video is about molar mass and how we can figure out how much 1 mole of anything is going to weigh. What is its mass going to be? All right, so if you look at the mole concept in the previous video, you'll know that we use the periodic table in order to determine this. Okay, the molar mass is the mass of 1 mole. And you'll see they have these complex units, grams per mole. That means it's X amount of grams per 1 mole of the substance. Well, if you want to know where to find it on the periodic table, look no further than the atomic mass. Remember, the atomic mass is the weighted average of the isotopes. You use the relative abundance and the mass numbers in order to figure them out. When you're looking at the periodic table, what you want to do is you want to round all of the elements' masses to 2 decimal places. Okay, our reason for doing that, the scales that we use in class and in lab usually go out to the hundredths, go out to 2 decimal places. So we want to make sure that we have the same number of sig figs. The only exception to this, and the usual exception to everything that we do in class, is going to be hydrogen. Hydrogen's going to get 3 decimal places. So please go get your periodic table, pause the video if you need to, come back so that you can see exactly what's going on. Hey, you're back. Okay, so if you take a look at these 3 common elements that we use continuously, you'll see that the molar mass of carbon is 12.0107. Well, we need to round it to 2 decimal places. So that means we go 1, 2 over, make a cut, and then we do what Elsa says. If it's 4 or below, you let it go, okay? If it's 5 or above, you give it a shove. So we want to round this to 12.01. It is not 12.00. It has to be 12.01 because with rounding error, it would make a big miscalculation at some point later on. Okay, for oxygen, okay, you'll see it's 15.9994. All right, 2 decimal places. I make my cut right here. This 9 is above, so it gives it a shove, which gives this a shove, which gives that a shove, and we get 16.00 grams per mole. All right, and then hydrogen is our odd man out. Hydrogen is 1.00794. If we rounded it to 2 decimal places, this would be 12.01, and that's a little bit too heavy for the mass of hydrogen. We need to go out to 1 more decimal place and round this up to 1.008. You're going to use these 3 numbers so much that you're going to kind of end up committing them to memory. I'm not going to say you have to memorize them, but you use them so much that you will, by process of doing it so much, you will actually have them memorized. All right, so that's easy. Let's figure out how to do a compound, something a little bit more complicated. Okay, we have 118 elements, but we have over 4 million compounds. So how can we figure out the mass of any of those? So what we do is we take a look at the formula of the compound. Okay, NaCl, it's going to have a molar mass of 58.44 grams per mole. Well, how did you get that mass? Well, how do you get NaCl? It's 1 Na and it's 1 Cl, and you put them together and they bond together. So if you look on your periodic table, you'll be able to find Na, 22.99. Notice it's not 23. Yes, it's annoying, but you'll be fine. You'll survive. I haven't had anybody, have to go to the hospital because of rounding and being annoyed by it. And chlorine is 35.45. And then we add them together and you get our 58.44. And that's the molar mass of NaCl, NaCl, table salt. What if we have something a little sweeter? What if we have something like sugar, sucrose, C12H22O11? Well, it's like you guessed. We get 12 carbons, the mass of 22 hydrogens, and 11 oxygens. You look up each one on the periodic table. Do you have them memorized yet? Carbon is 12 point, that's right, 01. Hydrogen is 1.008. He's the one that goes out 3 decimal places. And oxygen is sweet 16. Okay, you multiply them across and you add them up and you get your molar mass of your sugar. Okay, so make sure that you take the time to put these in your calculator. 12 times 12 gives us our 144. 22 times 1 gives us our 22. 11 times 16 is 176. You know the shortcut for all this? Any two-digit number times 11? You take the 1 and you put it here. You put the 6 right here. And then what is 1 plus 6? That is 7. And that's how we get 176. So if I had 42 times 11, what's that going to be? A 2, a 4. It's going to be 462. So smart. And then you add them up. You get 342.30 grams per mole. Okay? If you have something in your compound that has parentheses around it, what that is it's going to tell you how many of a polyatomic ion you have. And don't worry, you'll learn all about polyatomic ions really, really soon. Okay, so Al2SO4 taken 3 times is the same as saying I have 2 aluminums and then I have 3 SO4s. So I have to take this 3 and distribute it to both parts of the ion. Remember, every capital letter is a new element. So I need to count aluminums, sulfurs, and oxygens. I have 2 aluminums. I have 3 times 1, or 3 sulfurs, and I have 3 times 4, which is 12 oxygens. So that is a very common mistake, is that people forget to count the 3 sulfurs and the 12 oxygens separately. Sometimes they add them and get 7 instead, so you want to make sure that you're really comfortable with those values of 2, 3, and 12. And then you do exactly what you would have done before. Look on the periodic table. All right, we have 26.98 grams per mole for aluminum, so 2 of them is 53. 32.07 for sulfur, which is 96. Oh, here's oxygen again. I have that memorized. It's not 15.999999. It's 16, which is 12 times 192, and we get our 342.17 grams per mole. Okay? There are actually 3 ways that we can categorize molar masses. Okay? Molar mass is a general term, like students. All right? You can be specific and call it a gram atomic mass, a GAM, gram molecular mass, a GM, or a gram formula mass, a GFM. And what they are would be specific. Like if we were like, oh, these are the 10th graders, these are the 11th graders, and these are the 12th grade seniors. Okay? So it's just specifically talking about the differences between atoms, molecules, and formula units. Okay? So a gram atomic mass is the molar mass of an atom. And remember, atoms are elements, so any of the 118 elements on our periodic table. The gram molecular mass is the mass of a molecule. Molecules are non-metal compounds. And if you remember on our periodic table, what side are our nonmetals? These are our nonmetals over here. So that counts for nonmetals and the exception to everything, and hydrogen. So this is H2O and O2. There's more than one oxygen. That's your diatomic molecule of oxygen. CO2, P2O5, NH4, NO3. So when you figure out its molar mass, don't forget you have 2 N's here. And then you would have 4 hydrogens, and you would have 3 oxygens. And then lastly, the other type is the molar mass of your formula unit. And yes, you can say Fu in class because that's an ionic compound. A formula unit is this repeating 3-dimensional structure. It is a unit that repeats over and over again in a solid form. So NaCl, our metal Na is over here and our non-metal Cl is over here. This isn't a molecule. It is a repeating structure of Na bonded to Cl, bonded to Na, bonded to Cl, bonded to Na, bonded to Cl in a crystal lattice structure. And you want to make sure that you know the difference between those. And this is where you get like your iron bromide and you get your zinc phosphate. Don't forget about the 4s and the 2s and doubling what's inside. Okay, and lastly, we want to pay attention to the molar mass of something called a hydrate. Hydrate means it is an ionic compound that contains water molecules. They're basically stuck within the spaces between the ions. The space between, right? The famous example of this is Epsom salt. Epsom salt is magnesium sulfate heptahydrate. Hepta means 7. Okay, and the way that the formula is written is not with an and, but with this special little dot right here. That dot means plus. I know in math class it means multiplied by, but it's not multiplying by the mass of 7 waters. It means that you take the mass of Mg, S, and 4 O's, and you add the mass of 7 water molecules. All right, so if you take a look at this, here's your Mg. Here's your SO4, okay? And then we have 7 water molecules that are proportionally attached to it. 1, 2, 3, 4, 5, 6, 7. So if there is a 1 to 7 ratio, I need to account for that. All right, so other hydrates are the same thing. This is kind of like a poor thing to see, but like gypsum is going to have a dihydrate and borax is going to have a decahydrate, all these different kinds of hydrates that are in there. All right, so how do we figure out the molar mass of magnesium sulfate heptahydrate? Well, I have 1 magnesium, I have 1 sulfur, I have 4 oxygens, and I have 7 water molecules. So I would look on the periodic table for the mass of each one. Okay, magnesium is going to be 24.31 grams. Sulfur is going to be 3207. Oxygen is going to be 16. And water, you might as well commit it to memory, is 18.02 grams. You might remember that from the mole concept video. If you don't, it's okay. You can figure out the mass of the waters instead. You would do 7 times, and then you have 2 hydrogens and 1 oxygen. Hydrogen is 1.008, oxygen is 16. So you would have to multiply that value, which is 18.02, by 7. Yes, you could make 14 of these and you could make 7 more of those, but don't forget you have oxygens here also. So this is an option for you if that makes a little bit more sense. Okay? Then you multiply, you multiply your 24.31 across, 3207 times 1, 4 times 16 is 64, and you end up getting your water molecules. I forget the mass of it, but the whole thing adds up to 246.52 grams, and you have to write per mole. So you'll see on the next slide here, I have it worked out. There we go. It's 126.14. I forgot to write it down for my little cheat sheet. But that is our molar mass of magnesium sulfate heptahydrate.